Welcome this evening. This is the American Chemical Society December meeting. We are fortunate to have with us this evening Dr. Rob Strongin from Portland State University. About 6 years ago, a group of 3 faculty at Portland State got together and started tackling this question of what is produced in vaping formulations. They've made a lot of progress on this. They've probably stirred up some controversy in the process, particularly feedback from the industry. Rob Strongin, our speaker this evening, is a professor of chemistry. He teaches organic chemistry at PSU. I first met him at least as far back as when he was an assistant professor at Louisiana State University, and maybe when he was a graduate student at the University of Pennsylvania. He moved from LSU to Portland State in 2007 and has had a truly first-rate research group here at PSU. And vaping is not the only thing that's going on in his laboratory. Okay, we are trying an experiment this evening, which we hope will be able to continue in the future. This talk is made available by broadcast via YouTube to other members. We have just managed to set this up recently. Jim Tung is our ACS member who has done the work of setting it up. It's being made available in real time, and it will be recorded, and it will be available in the future on YouTube. And so those who have not been able to make the talk will be able to pick it up on YouTube. And by all means, feel free to promote viewing this talk on YouTube to your students and friends in the future. Okay, so without further ado, Rob.
Thanks so much, Warren. It's great to be here. Had a really nice time. This is a really nice meeting. I'll be back. When's the next one?
January.
Okay. We'll be in town, right? So I'll see you all again. That's really nice. Thanks so much for the kind intro. Of course, for the invitation. Thanks to Jim, and Dave, of course, and Martha, and the other organizers, and everyone here. Thanks to all of you for coming. It was nice to see some familiar faces that I haven't seen in a long time, along with meeting some new friends. So, as Warren mentioned, there's 3 of us in this project. Jim Pankale and David Payton, who I know some of you definitely know, 2 of the smartest people I've ever known, and 2 really great collaborators. But before I start, I want to say that anything I'm going to say tonight, especially since it's being recorded on YouTube, it's all my fault. Don't blame the NIH or the FDA, please. You can blame me. You can blame Jim or David too. It's fine. In fact, I prefer that. So, and also like to acknowledge our current and former group members on this project. And so, as Warren mentioned, we actually do other things, and it's Jim and David's fault for coming to my office one day with a proton NMR spectrum. Said, this is a really interesting peak over here. Can you tell us what that is? So that's what happens when you're an organic chemist sometimes. So, well, it turned out I couldn't right away, but actually David figured it out. He's the NMR guy. But they kind of changed my life. That was a pretty disruptive visit. Ever since then, I've been working on e-cigarettes. So we have longer-term projects making biosensors and molecular probes. This is work we do at OHSU at our lab at the RLSB, and also our startup pharmaceutical company making drugs to moderate calcium handling during heart arrhythmias. So recently published a nice review on e-cigarette analytical and organic chemistry. But it's already dated. It came out a few months ago. It's kind of sad, but it's kind of exciting that that happens. Week to week, day to day, there are new events. Usually not good, but and I'll talk about some of that. There are opportunities, but they're usually about people's health and things not going well. And I try very hard and feel responsible in a way to try to get the truth out about this stuff, because again, let me just also say up front, if you're trying to quit smoking, and you can do that with e-cigarettes, please do that. I'm not advocating against e-cigarettes. How we started off in this was to try to tell the truth about what people are really inhaling. Okay, so what's actually in the aerosols, not what's in the starting liquid, not the ingredients, but actually what kind of chemistry happens, and what's produced, what kind of toxins people are inhaling and at what levels, and what causes their formation. To counter the misinformation that's put out there, not anti-corporation most of the time, some of the time, but this is kind of turning me into a real progressive Portlander. I can't help it. I don't think it's because I've been here long. I think without this project, I'd still be pretty moderate. So e-cigarettes have pretty much, the design is very similar, a lot of variations, but there's obviously a mouthpiece. Not all of them have microprocessors and LEDs, but you need a battery, usually a lithium battery, and you have in the atomizer, that little thing with the window. You see the coils, that's a heating coil. Most of them have some kind of metal canthal, nichrome heating coil material that's got a wick either on the outside of it or the inside of it, or both, that soaks up the e-liquid, which supposed to contain nicotine to help people quit smoking. But a lot of the liquids don't contain that for some reason, and contain bubblegum flavors and things like that, with and without nicotine. A lot of the kids using these don't even know that there's nicotine in them. So, that's basically the design. Usually a cotton wick in tobacco e-cigarettes. In cannabis e-cigarettes, if you use cotton, people don't realize this, that don't use that stuff. And those of us that study this, the other people that know about this, if you use a cotton wick, there's a very good chance they'll catch fire. Don't do that. I don't recommend it anyway, no matter what the design. So there are several generations, and these are the tobacco e-cigarettes. That'll be the first part of the talk, and I'll tell you about our recent work on cannabis and vaping. We actually, just a few weeks ago, published the very first paper on the aerosol components and the toxins in vaped samples of cannabis oil concentrates. So the very first paper just came out. The phone's been ringing a lot. When we started that work, we had no idea that by the time it came out, there'd be an epidemic. There was no report of it when we began the work. Anyway, the first generation e-cigarettes were called cigalikes. They're the ones that you used to see the little light at the end, right? They look like cigarettes. And remember those? We don't see a lot of those anymore. You know why? You won't hear this probably anywhere else. I'm going to get in a lot of trouble. That's okay. It's nothing. So they found that wasn't such a great design to deliver nicotine. all these other generations, these more advanced types, the tanks, and of course in the center, we have the joules, right, the flash drives. They don't make nanoparticles to deliver the nicotine. So they found, oh, you know, if we change this design and go away from these cig-alikes, we get a much more efficient delivery nicotine, plus whatever else is in there, of course. Anyway, so the cig-alikes are still around, but they're not as popular, and there are all kinds of designs and all kinds of hobbyists and different interchangeable parts, et cetera, and so on. And there are the new IQOS that just take these little, they're short cigarettes, they're called HEETS, H-E-E-T-S, isn't that clever? And you put like 5 or 6 of them in there, and it's heating, it just heats them up. And you inhale, so it's also, well, it's not burning, so it's healthy, right? It's just heating the tobacco. We've studied those as well. I won't be talking about that tonight. There's only so much time before everybody is asleep. So what really attracted me to this, apart from working with David and Jim, is the fact that now, and when we started, these numbers were a lot less, but they were still significant. And we skipped the top one. All those, the 11 million adults using e-cigarettes in the US, they're all quitting smoking, right? So good luck. I wish them well. It's actually not true. I mean, I wish them well, but I don't think everybody's quitting smoking. Most people, and again, it's not that they're not trying to quit, but most people wind up these days being, I believe, dual users, which some studies have shown is even worse than just using one or the other. I don't know why, but that's what the statistics show. But what really got me interested in this was at the introduction of every one of my papers, the papers that I've written as part of the team, is about high school and middle school usage, especially by young people that never tried a tobacco, traditional cigarette. Right? So that is really concerning, and the statistics came out that e-cigarettes are now the preferred usage by teens, adolescents, and this has undone 20 years of gains in the drop in tobacco usage in the country. So it's back up to where it was 20 years ago now. So, you know, you can play around with these statistics. I see some wonderful mental gymnastics, if you will, about this on the internet. Don't Google my name. So, you'll see why. So, e-cigarettes are new products, and obviously they're still new, a lot newer than anything else out there still. And in the traditional cigarette field, it takes at least a generation, at least 30, 40 years till people get sick from smoking, right? I mean, you smoke a few cigarettes, I feel fine the next day. Maybe I feel fine. You're not dying of cancer or anything right away. It takes a really long time. So that is very daunting. How do you, if people are using these cigarettes, how do you warn them about this, right? Especially young people that are, people that really don't know about the history and the biology and the health effects of these things. How do you tell them this is a long-term issue that they're starting, and no one knows what's going to happen with e-cigarettes. But I'll talk about people that think they know, and tell you why we all need to argue against that, if we can. It's very interesting when you'll hear people these days with the current epidemic we've been going through say, are you kidding me? 50 people died of e-cigarettes? Are you kidding? 400,000 people died from tobacco. How can you compare this? This is like an outbreak. If this was bad lettuce, bad romaine lettuce at the store, you wouldn't be saying, you shouldn't eat lettuce. It's not healthy. But the problem is, you read about this on blogs anytime. I mean, it's very easy to find. It's a very well-organized group, by the way. And it's very simple. If e-cigarettes, no matter whatever the reason is, are killing people now after a couple of years, a few years. Maybe they're actually worse than cigarettes that take 40, 50, 60 years to catch up with you. So I actually think it's maybe a sign of something even worse. Because cigarettes, you can turn it around and say cigarettes don't kill you that quickly, right? So again, it's pretty daunting, and it's very difficult to argue with industry that's got billions and billions of dollars with a very large global presence. Another thing that we have to, and this is common sense, really, you don't have to really know much about history of tobacco or e-cigarettes or anything. The flavorings that are put in there, grape, whatever it is, right, all that stuff, we have all that in the lab. Not the brands, but the actual, the flavoring chemicals. They are advertised by, you can go on the websites, this is generally regarded as safe by FEMA, not the FEMA from hurricanes, but I think the Flavor Something Manufacturers Association. They're generally regarded as safe. They're safe. So e-cig people will sell you these flavors that they're fine. Look, FEMA, the agency, there's top agencies that say they're fine. But there's a problem with that. There's a slight problem. They're safe for eating. There's a difference between a stomach and a lung, right? There's a big difference. I won't get into it right now. Take my word. Why? But how come there's no inhalation toxicology on these flavor molecules? They're so common. You know why? Because nobody thought anybody would be crazy enough to be inhaling them. That's why. Nobody thought there would ever be a reason to study them. So now we're way behind. So, okay. What happened? Is that my next slide? All right. I had too much dinner. It was great, by the way. So, this is a challenging field. There are a lot of people doing a lot of things their own way. And this is just this little, it kind of looks to me, I grew up in New York, it looks like the subway map a little bit. But this is really a little flow chart of the different methodology to analyze e-cigs. So just to give you a little idea, this is in my review article. I actually didn't make that figure though, but I got permission to use it. So one of the big challenges that we see is, again, misinformation. E-cigarettes, as most of us know, I think, although you wouldn't, listening to some people talk even today, you wouldn't know it, that there's not a lot of water in e-cigarettes. There's almost no water. Maybe there's 10%, maybe, if you're lucky or unlucky. Robert West, Peter Hayek, and Clive Bates are well-respected tobacco control people from Great Britain that, I'm sorry, these are quotes from the first two I know from several years ago when e-cigarettes were first introduced, that e-cigarettes are no more dangerous than coffee. How do they know? They hadn't been around for, a year. And they are telling people that these are as safe as coffee. And again, if you're an industry person, do you like regulations? No. So you want your product to be known as safe, so the government doesn't step in and say, oh, you should put that in there, you should put this in there, you're gonna get fined. So regulating e-cigarettes, if they're no more dangerous than coffee, would be like trying to regulate coffee. What, are we crazy, right? So Clive, I have a very special kind of relationship with. Clive is head of, apart from other things, I think he's kind of retired from his tobacco control work, but he I think is involved with a group called R Street, and he crafted the paper to try to get our New England Journal of Medicine manuscript retracted, which failed, by the way, it's still there. And he works with a company, I mean, it's not a company, it's a lobbying group. It's called R Street, it's in Washington, now they all are some kind of street, R Street. It is this is really nice, I don't think those go over too well in Portland. It's a conservative, libertarian think tank. Okay, that's kind of who doesn't like us a lot. And, oh, by the way, a lot of us here are chemists, right? Raise your hand, no, don't do that, it's okay, please. The lowest size particles, so people are saying there are nanoparticles, you're breathing nanoparticles. That's gonna go right through you. And you take all these toxins, you know, the drug delivery, the delivery mechanisms, this stuff is so small, it's gonna go right through your lungs, right into your bloodstream, right through everything. And Clive says, you're all crazy. You're all crazy. By the way, he's not a chemist, so we'll forget it. The lowest size particles, which are nanoparticles, are water vapor. Now, I have nanochemist friends here, several, one good one. And is there such a thing as a water nanoparticle? I mean, if you find one, if you discover one, let me know. I'd like to publish a paper with you. We won't show it to the EC people. But just so you know that there are some really strange things out there. Why? Because the tobacco industry started alternative facts. They invented the whole thing. They started it way before the current people that we all know about on the news every day. Years and years, a generation before. So, and this is a shame to hear this from people that should know better. And these are the people that are up against us. And okay, I wish them luck. I hope someday they come back down to earth. So what people do is what the industry people and the backers do, and scientists who don't know how to do much else, that from the tobacco industry, I don't mean to put anybody down, especially not colleagues in the tobacco industry, they compare e-cigarettes to traditional cigarettes. Now think about this. When we hear that e-cigarettes are so much safer than cigarettes, which they might be, I'm not saying they're not, but the way people are arriving at that conclusion is by taking the worst chemicals formed when you combust a cigarette and smoke it. So acrolein, formaldehyde, goes on, nitrosamines, all that terrible stuff. And you look at that, and then you measure the levels of those things in e-cigarettes, right? And you know what? There's not as much. So guess what? E-cigarettes must be safer. There's a problem with that. There's not even anywhere near close the same stuff in there except for the nicotine. How can you know what I'm saying? You're comparing the one without going back and looking at what's in e-cigarettes that's not in cigarettes. And there's a lot of stuff in e-cigarettes that's not in cigarettes. Propylene glycol and glycerol. There's a lot of that. They're the solvents. How would you like your son or daughter to be inhaling 20 milliliters a day of propylene glycol and glycerol? Does it sound good? I know, I wouldn't want Dave to. Right? So, okay, and this is not rocket science. The chemistry of propylene glycol and glycerol especially. Let's go back to Carl Scheel. Anybody know? Is he coming next month? No, so he studied glycerol because he was studying, I guess, hydrolyzing fats, fatty esters, triglycerides, excuse me, back in 1779. I think that was before ACS, right? It was only been 3 years there could have been an A in the ACS, right? So a long time before Wöhler's urea synthesis, right? This is like old chemistry. I love old chemistry, right? So, and John Neff, great organic chemist, right? Legend. All the propylene glycol and glycerol chemistry, he did in like 1902, he published. I know, I have the papers, Rob Jensen gave it to me. So, what do? Well, we try to use different methods than what people are using to compare the toxins formed in cigarettes to see if they're formed in e-cigarettes. We're trying to go back in the other direction. What happens to the things that are in e-cigarettes that aren't in cigarettes? To try to balance the equation here. There's a great deal of interlaboratory variability. which is caused for a number of reasons. It's not easy work to do. It's not easy to get reproducible. There are no standardized methods. Everybody does everything their own way. And you'll even see people that say they replicated our work. It's totally different. I mean, unbelievable. So we started out, Rob Jensen, Dave Payton, myself, and Rob, of course, did all the work, right, because he's a student. And look at the chemistry of propylene glycol glycerol. I answered the emails. Anyway, Rob did all the work, and I had fun looking at the mechanism. So basically, what happens to propylene glycol glycerol? Well, we found that you form formaldehyde from propylene glycol glycerol, which Neff and even Shield probably could have told us, but certainly Neff told us, yeah, it forms plenty of formaldehyde when you heat these things up, even around their boiling point, right? And you think, wait a second, aren't people heating these and vaporizing them? I got an email a few weeks ago that said, who's paying you to write this? There is absolutely no formaldehyde in e-cigarettes. The address was it was like a phony email. Anyway, there wasn't anybody here, right? Okay, so good. I hope not. So what we found, and no one had reported these before, were the hemiformals. Jim Pankow won't let me say that email, it's correct. The hemiacetal of formaldehyde is actually hemiformal, all right? And there are 4 of them that we can see, as I think depicted there, right? And on the bottom right there. And very interesting. And this was these were the compounds that were in the NMR that Dave and Jim came to show me that eventually got sorted out. And, you know, they look pretty innocuous, right? And, you know, in our paper, we actually showed if you account for these, which weren't accounted for by the way people were using traditional cigarette methodology to look at these toxins in the aerosols. If you account for them, we actually found in this older generation, crappy e-cig, right, you're getting more formaldehyde formed than you would in a regular cigarette. And people got really mad at us. But regardless of what the level is, these are all in equilibrium, right? These hemiacetals and formaldehyde, et cetera, and so on. And so what happens is if you put formaldehyde in this formaldehyde releasing form, which is a lot like the way the fragrance, not the fragrance, the skin care, the hair care industry does. They don't say it's formaldehyde, it's some other thing, but when it gets in your skin, et cetera, it reverses. So these we call formaldehyde releasing agents. The thing is that Jim calculated that these formaldehyde releasing agents, when they're inhaled, there are 2 phases of an aerosol. There's a particulate phase, which is a misnomer. It's actually liquid droplets that are kind of particle-like. That's the kind of misty thing you see coming out of the spray cans, I guess. And then there are gases. There's this gas phase and a particle phase. Formaldehyde obviously is in the gas phase in an aerosol, free regular formaldehyde. But when formaldehyde gets trapped in as a hemiacetal, it now goes into the particulate phase, which makes sense, and then Jim calculated. What that means is formaldehyde, it's controversial, it's pretty well accepted, it's carcinogen, but it's highly suspect. It usually causes nasopharyngeal type cancers. That's the ones been associated with. Because the gas phase particles typically, you know, they stick, they don't get down in the system. But the particle phase and the smaller particles go farther down the lungs. So essentially, what we're saying is that this is a way to deliver formaldehyde deep into the lungs and into the bloodstream directly by a different route than just leaving it up here in the throat, which is kind of not a nice thing, right? Because these are in equilibrium. If you put these in water over time, they revert right back to formaldehyde. So that's pretty significant. That's why we put it in the New England Journal of Medicine. And we also found, I should say Rob, while I was checking email, also found all these other compounds. Glycidol, that's a nice one, right? A nice universal electrophile, also a carcinogen. And some of these others that I'm going to talk about. By the way, you're probably thinking, what about the acetals? That's why I couldn't tell them what that was right away. He said, well, you have to be forming. I wrote an organic chemistry textbook once when I wasn't feeling well. And I happen to know that acetals are more stable than heavy acetals, or else you're not going to get either one. Well, formaldehyde's different. I can tell you that the formaldehyde hemiacetal is easier to make than the full acetal of formaldehyde. If you add acid, you'll convert the hemiacetal to the acetal. If you don't, if you keep it neutral, it'll stay as the. We've bubbled formaldehyde into this solution and got an NMR. It looks exactly the same as what we get in the aerosol. Absolutely very surprising. I had someone come up to me at a conference at the NIH and said, "What do you know? It's cyclic hemiacetals that are stable." I said, "I know, I wrote a textbook." I knew before that, but I was really shy to be really sure of that, right, Dave? It's hard. So actually, yeah, glucose. This is formaldehyde. It's different. Very, very neutral. So, yeah, we worked out that basically what happens are oxidation and dehydration reactions. It could be through oxygen, but also it's been proven since that hydroxyl radical is formed, and again, that's going to start your oxidation reactions. This is how a lot of these compounds are formed, and these are just the ones that we found were formed from glycerol. Right? Some of the intermediates are presumed, but they really couldn't be anything else. And from propylene glycol, similar story, right? A little bit different. There's more acrolein, very nice compound, right? Terrible air pollutant, terrible irritant, not known as a carcinogen, but known as a very notorious air pollutant and something that will give you some really bad cardiovascular disease pretty quickly. That's formed mainly from glycerol, we found, us and then others a while ago. And again, this all follows the chemistry that Scheele and Neff and these people knew about a couple of hundred years ago. It was great because in writing the papers, we cite all these historical things that nobody cites, and we cite stuff from 1700s. I really like that. Who's going to say that that's the wrong citation? Right? You have to work really hard to get those, to actually see the real papers, which we actually have, most of them anyway. So, okay. So we were able to work out this reaction pathway, and you're heating and free radical formations. You get oxidation, you get dehydration reactions. Right? That's basically it. And then you can do almost any permutations and commutations from propylene glycol and glycerol that you like. And yes, there are less, typically less of these formed, especially in the newer e-cigs. I'm not saying they're better, I'll tell you why. Of formaldehyde and acrolein. However, that counts, I think, for cancer. If you inhale low levels, chronic low-level inhalation of formaldehyde, et cetera, and so on, acetaldehyde, acrolein, you'll still get cardiovascular disease, just as if you were inhaling levels 2 or 3 times or whatever as much, like from a cigarette, right? And Arun Bhatnagar, I think he's at Alabama, very well-respected guy, is one of the people that writes about this. I got these slides from one of his, it's not slides, but the graphs from one of his papers, showing that showing at what levels formaldehyde causes the problems listed in this chart, showing the problem. Even at these really low levels, you're still going to have these problems, and again, chronic usage will lead to cardiovascular disease. And what we found, and other people since, is see how where they blew, I don't know what you call it, a super parentheses or something, half up, right? See where it goes up to, it's off scale, because that's the levels that we got to, that we're seeing in some of our, and also down as low as a lot of the other people as well. So you're in a range of cigarettes and conditions. Same with acrolein, and acrolein, of course, is a very reactive electrophile, and the ocean work limit is pretty low because it's pretty dangerous stuff. You really, you want to stay away from it. If you're around too much of it at once, you'll know. You'll start crying without wanting to. It's a terrible lacrymator, I think. And it'll also polymerize if you look at it long enough, too. So it's also probably not going to form some too. So, okay, so these are compounds, some of which are unique to e-cigarettes, some by coincidence are formed in cigarettes. We just studied the solvents, these solvents that are there. And there's a little bit of propylene glycol, maybe a tiny bit of glycerol in traditional cigarettes, not solvent levels. So these are significant characteristic reactions of e-cigarettes, where, you know, there are like I said, there are people that vape 10 or more, at least milliliters per day of e-liquid, doing these reactions and taking them in. So Clive Bates and Konstantinos Farsalinos, and they wrote letters to the New England Journal of Medicine editors to get our paper retracted, that didn't work, so this other agency, Pinney, P-I-N-N-E-Y, Associates, also in Washington, that is a consulting agent to the tobacco industry, leaked the retraction to this thing called the retraction watch. It's hysterical. They're calling me up. I said, what do you think about this? I said, nothing. I said, let them say what they want. Go ahead, print it. You'll see. All right. But it's just a shame because people are going to believe this. PubMed, I think, stopped for a while. They were having people write comments about papers. And you see they don't do that anymore. Maybe it's because of us. People writing. We'd have 50 to 100 comments calling our papers junk science when you would look for them and find them in PubMed. It's all gone. It's all taken away. Okay, it was really nice. And the main thing they said, the strategy is vapors will be able to tell if they inhale toxins. Well, yeah, to a point, of course. If you're inhaling 100% formaldehyde, you're probably going to stop doing that, hopefully. Right? You'll know. But how much is too much? Can you really tell me that every single person that is inhaling an e-cigarettes, as soon as you reach a dangerous level of one of these toxins, it's just going to stop because it tastes bad, right? I'm serious. This is the whole thing. They said this is crazy. It's like would you eat burnt toast or regular toast? This is the kind of thing they're writing to us, right? Because I drive my car. My car goes up to 220 miles an hour, but that doesn't mean I'm going to drive it that much, that high, right? And so this is the whole argument, and that we were actually abusing the e-cigarettes. What we were doing was purposely heating them up so high that all the liquid went, and they actually invented a term for this. They called it dry puff. So they're saying that we don't even have solvent in there, which doesn't make sense. Because there's nothing to form the toxins, right? And anyway, let's go on. So we've published again about the hemiacetal. We showed why nobody else was seeing it. It's because they were using DNPH, which reacts with aldehydes, right? Dinitrophenylhydrazine. It's the EPA method, but they never tried it with formaldehyde hemiacetal. And it's an acidic solution. So you put it in there, it converts to the acetal, it's gone. They have no way to detect it. And they're using these cartridges, which have a solid DNPH on them. And I want you to see, take a look at the bottom footnote. I have a nice arrow there. Everybody's using these reporting alkaline levels. And I'm looking at our box, and I'm looking at the papers, and you use the same thing as us. And it says this on the box, and you're saying, there's almost no alkaline in here. I mean, really? We use NMR. That's right, we use NMR. We're organic chemists. We don't know any better. Right? I mean, I use the HPLC, but, that's hard work. That's the only good thing about it is I can check my email while that's running, right? So we have a smoking machine. It's just a vacuum, right? But you can program it so you can get consistent results. We have a couple of impingers. So you pull the aerosol, you hook up the e-cigarettes, you go into a couple of tanks, and you collect this stuff, you wash it out in an NMR solvent. You have DMSO D6 right in there, just put it right in the NMR tube. Totally non-destructive. Of course, you're reacting alkaline with DNPH. Do you think that's an efficient reaction anyway? No. It's not, I know it's not. Forms dimers, trimers, gazimers, all that stuff. So, oh, by the way, in the circles there, it's a beautiful NMR. See, you see that? They say there's almost no alkaline form. Well, look at the aldehyde region that's circled there. See that, what looks like a nice doublet, that big doublet? You can't miss it. Seeing is believing. That's alkaline. The other stuff there, there's some acetaldehyde. But they say there isn't any. It's okay, use NMR. You just take, you collect the sample, you don't react it with it, you just take it, you put it in the NMR. It's non-destructive. It's the alkaline, which is very reactive, you get to see all of it. So, yeah, here's the whole aldehyde region, just blown up. Again, nice work, and all confirmed, and you know, it's great. The peaks are very well resolved, and we can clearly identify all these. And so, this was the second attempt using human subjects to say that our work was trash, that nobody would use our conditions. And so these researchers, what they did was they said they did a replication study. So they didn't look for the hemiacetal of formaldehyde, which is the whole basis of our work. They didn't use NMR. Right? But all they had to do was say, hey, we proved them wrong. Right? So they got low levels of formaldehyde, like they always do, because they're missing so much of it. And they said, see, those guys at PSU are nuts. We told you that they were, you know, they were creating junk science. So, yeah, and you know, I just think the substance isn't as important as what this, you know, that it tells people, hey, we won. You want to know the details? No? Okay. So that's what it seems like. So yeah, vapors can self-regulate toxins, right? So I got this email right at the EVOLI when we talk about the outbreak this summer, right in the middle of it. I was at the ACS meeting talking about this stuff in San Diego. And I received this email, and this young lady, she's a single mom, struggling to get through school. Put herself through school, she's trying to quit smoking. She heard e-cigarettes were healthy. And she said that she can't afford to replace her heating coils. Right? And so she realizes now, after the EVOLI outbreak, she's starting to get worried. And she started to look at what was actually in her e-cigarettes. And she realized that she had gotten used to the taste, the burnt toast. And she was perfectly fine with it. And we have what are called trip receptors that make us less make us habituated to harsh things like that. This poor lady, I had a long email exchange with her, and she was just great. She told me, use my name, tell everybody you can about this. Okay, so all right, so it's one person that wasn't stopping herself from inhaling probably really bad levels of toxins with every puff she took. How about this guy? Right? Are you going to tell me that he knew when to stop with the vaping? Really? So, it makes me really mad. I'm sorry. So, we published a replication paper of our replication paper recently, of their replication paper, of our replication paper, right? And we actually, since our methods have improved, because it was 3-4 years later, we actually found more formaldehyde than we did in the original paper. But what was really amazing, I'll tell you, let me tell you, so look, see the title? It's almost the same as the other one. Instead of saying reported to be averse, I put the non-averse. Right? So they know people would know the papers are linked. All right? This is a rebuttal to their rebuttal. And basically, yeah, we totally validated our work, which we didn't have to. They wasted our time. But the important thing is that even in their paper, it was crazy. They did a human study to say, oh, they'll stop when it gets to the dry, what they call the dry puff, right? When you get high levels of these breakdown products. So it took 20 people, experienced vapors only. They asked them, tell us when this tastes bad. And what they did was they had them in a room vaping, and they started with low power, higher, 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 higher. And they did like 20 levels. And of course, they told them what they were looking for. And you know, after 10 things, and plus they didn't randomize it. Like you go high, the low, and into, right? They did it in order. And they let them publish this. And the worst part of it, 20% of the people didn't stop in time. Anyway, under even the best conditions. Of course, they didn't say that. If you look at their data, you know, the last sentence is, we'll also try to figure out why some people have different taste evaluations of these things, right? All right, so really, so, okay, so new generation e-cigs, some of which I showed before, these tank mods and these cigarettes with very enhanced airflow. Now they have these vents, you can open the vents and get, that's how the people that make these big, huge clouds, you know, at the bus stop, right? These huge, they actually have conventions, you know, contests. Seriously, they're competitions. And they use these big, loose airflows, e-cigs, right? And the airflow rate is much higher because you've opened it up, right? So, you know, there's nothing, you know, there's no resistance. So you get these huge puffs, you win the contest, and they produce less of the breakdown products because there's less heating, right? Think about it, it makes sense. You're going way faster over the heating coils, et cetera, and so on. We found there's actually different kinds, a different profile of toxins for too, but at lower levels, which makes sense. But the problem is, you're inhaling so much of this stuff that they've reached the grass food level for propylene glycol when they do this. So it's like, oh, you don't want to have toxins? All right, just inhale, you know, 25 whatever milligrams per day of propylene glycol, and you're past the, you know, what they say you're not even allowed to eat. So that's the story. Now, the same people that challenged us, you know, when we started, we and other colleagues started looking at all the flavors. We wanted to get a baseline first of the solvents. They're the most abundant things. And also there's 8,000 different flavors, and that was 4 years ago. So, you know, we kind of wanted to put that off a little bit. The good news is those are just, a lot of the time, different combinations of the same chemicals. One of the most abundant chemicals, flavor, it's not really a flavoring, it's more of a flavor enhancer, is triacetin, which happens to be the triacetate of glycerol. And people have even suggested using this instead of glycerol. Why? Because they know the other stuff's toxic. And you figure, well, these are protected, right? There was a controversy after ours. They started to forget about us, right? I felt kind of bad. Right? So my friend Andre Klista, who's a friend now, I didn't know him back a few years ago, he said flavoring compounds cause even more aldehydes to form, more breakdown products, 2, 3, 4 times more than and Farsolino's the same person who wrote a replication paper about us. He wrote a replication paper about it. I said, they're statistically insignificant. And he said, nobody can tell us why. Why would that happen? Why should they? So, oh, well, we'll show you why. So basically, did a very simple experiment. Well, first of all, we saw for ourselves that if you add the amount of triacetin that's usually in flavored e-cigs, you could see the blue peaks, you could see acid aldehydes raised, the alkaline levels are raised without even trying. The hemiacetal formaldehyde levels are higher. Oh, by the way, it's NMR. The other groups that are tracking our work, I don't know if you use it. So I don't know what's so hard about it. To me, it's way easier than HPLC. You just have to ask Anna to train you, right? So it's easy. So basically all we did was we made carbon-13 labeled, we got carbon-13 labeled acetic acid. It's not very expensive. Oh no, it was the anhydride. I reacted it with glycerol, I mean really. And we saw it spits off acetic acid, which was known 50 years ago in chemistry of triacetin. And basically, guess what? We know that there's a catalysis, that there's dehydration reactions. So if you're creating acid, guess what you're going to catalyze? when you heat all these alcohols. So guess what? You're gonna get more of those dehydration products. It's pretty, so, but they still don't believe us, even though we showed the mechanism with carbon-13 labeling, et cetera, and so on. So let me talk a little bit. There's a lot more. I can keep going for a few more days about all the work we've done the last few years. Just on the tobacco front, about how you know, the Juul people and David and Jim really started this. We did it with the IQOS, the other new brand of e-cig. But you know, the Juuls, which everybody knows by now, but they knew was we knew about this about a year or so before they became really famous. We published a paper on them producing benzene. And Juul people called me. We were in Philadelphia for Christmas, and I got a call from a headhunter who said, "We would like you to consult for a company." And I said, "Yeah, okay, I'll talk to you later. Bye." So he called back, and it's Juul. And no one had heard of them yet, and they were being sued and all this stuff. And we had a nice talk, we were laughing on the phone for an hour. They said, "Have you published anything about our e-cigs?" I said, "Oh, yeah, sure." He said, "Can you send us the paper?" I said, "Sure." Never heard from him again. So they, apart from putting in the flavors for kids and again, making the flash drives, the nicotine is the highest of any e-cig. There's as much nicotine in, I don't know how many packs, at least a pack or whatever of cigarettes. But the more notorious thing is it's all the protonated form of nicotine, which is the non-harsh form of nicotine. That's why so many kids don't even know that there's nicotine in these things. They can't taste it. It's not harsh. And then you put in the flavors, and it's just like candy, right? And they're safe. They taste like fruit. Right? So it's pretty insidious. I loved it watching those teens on in front of Congress. The Senate, I forget. I try not to pay attention these days. Saying how the Juul rep came into their school and asked the teacher to leave the classroom. And when the teacher was out of the room, they told him the Juuls were safe, totally safe. So they can't lie in front of Congress. Who would do that? I don't know. That's not pursued. Anyway, we got interested in cannabis too because, again, the same thing. In 2018, 2 papers came out, surveys. Over 2 million U.S. middle and high school students used marijuana in e-cigarettes. Reported, admitted, all right? I said, well, we're like so ready to just study that. Of course, you know, this stuff. So we go down the street and get some, right? No. We had to have the lady, the DEA lady, the Hank, whatever, come down from Seattle, right? And we had to buy a $2,000 safe and all this stuff. And we can only use analytical standards, right? Until I get a NIDA grant, which I'm hoping to get soon. They're totally interrelated. Cannabis has been mainly associated with this outbreak, EVALI, that's e-cigarette and vaping associated lung injury. EVALI, terrible acronym, but that's what government likes. So we'll call it EVALI. They'll pay us for saying that. We'll say it all day. Terpenes are the second most abundant class of flavorings in tobacco e-cigs, and also the second most prevalent type of molecules in these THC oils, vape oil. And we were doing this last year, I mean, way before this outbreak started. We didn't know. We didn't know people were putting anything else in these things. We thought it was just THC, it was concentrates. We thought people just wanted to get really stoned really fast. And they were in these oils that they're distilled and all that, right? Why would they put other stuff in it? Well, after a while, it made perfect sense. What do drug dealers do, right? They cut their stuff so it lasts longer, right? And they make more money. So that's basically what's caused this current outbreak. But also the fact that the tobacco people for years have been saying it's safe to put in whatever you want, whatever flavors, anything you want into these things, and vape them. You know, we were bound. Somebody was bound to one day put something in these vape pens, or e-cigs, whatever you want to call them, that was going to hurt people, right? It was just a matter of time. So the concentrated cannabis oil that had been in the news, like big time, starting early this summer, is butane hair oil. What people were doing now, it started out with butane hair oil. Remember the houses that were blowing up? Right? There was one in our neighborhood, remember? Right, so it still looked like a bomb dropped on it. People making butane hair oil. We don't know if butane's a little flammable, right? So, they're probably doing a wash or something. Spark, I don't know. The poor guy. But anyway, what they do now is they take that and they distill it and make it products called distillate to get really pure THC. And then they add back the terpenes because THC is so viscous. You don't want to even weigh it. We don't even want to weigh THC. It's terrible, right? And so people add back their own terpene formulations. You say, well, why do we add more and more and more? And then add? But then what happened was the users were saying, this isn't the concentrated good stuff. This is bad. It's liquid. So then they had to add thickening agents. Yeah, I'll tell you about one that nobody else knows about, and at the end. But anyway, THC is also a terpene. It's a terpenophenol. And we studied terpene chemistry. Well, not us. I mean, we did. But again, we're repeating old chemistry, atmospheric chemistry. Right? Terpenes are out there. The atmospheric people know what happens when terpenes oxidize, right? And guess what? We're seeing the same products. Methacrylin, methylvinyl ketone, et cetera, and so on. A whole slew of products. Now, there's another way of doing these, and you may have heard about this. It's called dabbing. So apart from the vape pens, there's the dabbing. The dabbing is putting this material, these concentrates, onto some kind of metallic or ceramic, etc. surface, and it's called flash vaporization. In other words, you heat it till it's red hot, and then you breathe all that stuff. It's so nice. Right, well, I'm not saying you. I'm saying one does that. So we made a dabbing setup in our lab. Here it is. It's really simple, and we couldn't use the smoking machine because to get all of the aerosol from this, we just used a pump with a meter, right? Because in order to get the full lung volume. And we analyzed the gas phase products, and this was our first. This was 2017. It's the most accessed article in the history of ACS Omega, which it's been around a few years, but it's still about like 90,000 views. I wonder why. It's probably because the science is so brilliant, right? It's not the topic. Right? It's definitely not the topic. Okay, so, all right, so terpenes are the next most abundant after the cannabinoids in the plant itself, but in the concentrates. And we use 90-10 THC to terpenes. And here's how the terpenes can interconvert. There are a lot of them in the acid form, and as soon as you heat them, they lose CO2. You get isomerization and rearrangements, obviously oxidation, etc. And so on. Delta-9 THC is the one that that's the money compound, I guess you'd call it, for lack of a better term. That's the one. And then, of course, CBD as well is the second most popular these days, because that cures everything, right? Okay. I'm sorry. I'm sorry, everybody. So, please, if it works for you, keep doing it. And I don't want to hurt anybody's business. And so, except if you're, selling bad stuff. So, this is the chemistry of terpenes. It's pretty boring. Form isoprene. Guess what? I wrote a textbook. Except in a textbook, it goes the other way. Right? You're forming. So, all right. So if you take the finished product and you heat that, it goes back. All right. So what is it? Microscopic reversibility? Except this is macroscopic. It's pretty good. All right. And you know what? THC does the same thing. Why? It's a terpenophenol. So you form all these products. Here's all the levels from dabbing, pure THC, so with a flash vape with the dam. The nice thing about that, doesn't matter if you have a rock or the most viscous material in the world. You can just put it on there, not a big deal. And you can't put it in the vape pen, that's too hard. Or you can put the whole liquid, the terpenes on there too. And so we can get controls this way. And the chemistry is pretty similar, whether you, the levels are different. We get higher levels with dabbing, but the products are pretty much the same. We see a lot of really nice things. Isoprene, ethylbenzene, styrene, that's a good one. Xylenes, benzene, methacrylin, a loose cousin of acrylin. And you know, I talked at the ACS meetings, a lot of industry people, a lot of nice people, and they say, that's not as bad as acrylin. I say, no, it's not. It isn't. But it's still not good. It's not as bad as acrylin. So I'll give you that. And these levels aren't that high, but again, the people using it, remember, Ottniger is really brilliant cardiovascular expert, has shown this, that with cardiovascular disease, unlike cancer, it doesn't really, the levels don't really matter as much. It's the chronic use of low levels is bad. But the people using this also are kids, and you don't need these things, just what THC does to a teenage brain is enough, probably. But you also have people with cancer and compromised immune systems being exposed to these things as well. So I think it's really important to know what the doses are, how much of the cannabinoids are left over. How do you even know how much you're giving your patient? You change the vape pen, it's going to be totally different. Because I got to tell you, the quality control is not so great, right, in this industry, so, at least not yet. So we found that 10% terpenes did not give as many of these degradant products, these gas phase degradant products, as the 90% amount of THC. So I tell the terpene vendors now, I have one on the phone today, don't use a lot of terpenes. Don't go higher than 10, 20, no more than 20%, because you're going to start exponentially increasing the amount of these toxins. That's probably one of the most important things that we found in our thing. Plus, this was the first time anyone showed that benzene can form from THC, believe it or not. It's very interesting. Why do you think the last paper on THC chemistry that we could find was published in 1972? It's federally illegal. Nobody can work on it. So how did we do it? Well, I have my get out of jail free card. No, we were crazy. We are dedicated, well, let's say dedicated. We bought HPLC analytical standards from Aldrich with our DEA license and vaped that. Okay, let's think about that, sorry. But those days are gonna get better. So what about this outbreak? It's vitamin E acetate. Everybody, I think, that's been paying attention to this aspect of the news knows that vitamin E acetate, or tocopherol acetate, was found in the bronchial lavage fluid of every patient with Avali disease that had been studied, which is like 26 people. But this is the one thing that was consistently found. So my worry is that that's it. Okay, just don't put this stuff in and go ahead. This is it. This was the whole thing, and now it's okay. Well, it's not. So somebody gave us one day, a guy that knows a guy, I guess, and knows a guy, and knows another guy came, and he said, hey Rob, I got a present for you. I said, what? He said, it's not, there's no THC in it. I said, but a guy that knows a guy, et cetera, and so on, he's not a nice guy, but I think he has a conscience. He gave us these vials, and he said, you know, we're selling this to people, there's no cannabinoids. Can you tell us what's in it? I said, well, he's selling, he doesn't know what's in it. You're right, he's not a nice guy. So these are thickening agents, you can tell by looking at them. Well, one was just pure vitamin E acetate. God bless you, Dave. And the other, the other well-known cutting agent are medium chain triglycerides. And I think about that. They're in a lot of these products. They're sold in dispensaries. And medium chain triglyceride is something that you take because it fools your body and you lose weight. These aren't the real fats, right? So your body is fooled and you lose all this weight. It hasn't worked for me, but I'm a very hard case for that. So I would be afraid to vape medium chain triglycerides because you've probably heard about liquid pneumonia, which is caused from lipids getting in your lungs. Jim reminded me, you know, when people go to diving bells, and I said, what are you talking about? I never did that. I grew up in Brooklyn. I know it's crazy. If you have any oils in there and you breathe it, you get lipoid pneumonia. I said, oh, okay. Is that what people are doing now? They're putting THC in the diving. He said, no! So, triglyceride to me is a fat and oil, so people are using it left and right. We found some other stuff in the other vial that we're about to send in and publish. Jerry has found, we looked at this, and Alicia, right? And Jerry didn't want to come because he knew I'd embarrass him, but Alicia's very brave. This is something called pine resin. Rosin. I can't tell. I had to find the right slang term. And when I did, all of Reddit lit up. I'm serious. And it said that use of this has been increasing in the last 5 years. And you know what this is? It's also called, I think the more scientific name is colophony. You want to call it that, right? It's rosin sounds a lot better. It's abiotic acid, etc., and it's esters. It's a mixture of stuff. Plus there's this other thing called oleamide. It's a known hypnotic. And it turns out that people are putting these in the THC cards, and nobody, except you guys and me, Jerry's, know about this. Nobody in the popular press whatever knows it. They will when we send out our paper in the next day or two. And this is, the problem with this is it's very unstable and toxic stuff. It's well known to form lots and lots of breakdown products like formaldehyde, acid, all the usual suspects. And this is why people that, when they inhale solder from soldering irons, you know, the stuff that, of course I never do any mechanical work except for email. So, if you breathe that stuff, I wouldn't breathe it. But this is supposedly the active ingredient that makes you sick from breathing solder fumes. Solder fumes. I know it's hard to believe, but you can look it up. It's the same stuff. We bought an authentic sample and compared it. Everything. It's totally proven. And people are putting this, it looks like a steroid, but you know, it's still, that is just abiotic acid, just one of the ingredients. The esters of it, et cetera, and so on. Plus the oleamide, plus medium chain triglycerides are also in there. So there's a total cutting, and it's really thick. It looks like Jell-O. That kind of consistency. For people to put back after they've diluted the THC too much with the diluting agents. So that's it. That was our latest work, and I thank you. I don't know, did I go over too much?
Rob would be happy to answer a few questions. Anybody have any comments, questions?
Yes.
Start way back there with you, Ken.
I really appreciate the detail of the analysis and your strong support of NMR technique. On your terpene analysis, your essentially independent variable was voltage on the vaping. And if we're talking about filament heaters, they're not typically linear devices as far as the energy. Is there a way of actually getting at some numbers on power or energy or temperature, or as opposed to just voltage on the device?
Yeah, we use power ultimately, and you know, it is, you're right, and it's very hard to get good replicates The herb bars are big. Rob J, if you were here, Rob, you here? No, okay. So he would tell you that we took the same replacement coils, the same manufacturer sold with the same e-cigarette, used the replacement coils, got completely different results. This was vaping, just the tobacco stuff. So it's very, and it's one of the, and you're right, it's one of the big reasons for the difficulty in interlab, let alone intra-lab reproducibility. And it's not perfect. We're using typically machine vaping and machine dabbing. So it's really an approximation more than anything else. That's the best we can do. But at least by using the automated systems, we get it as close as we can. And we use power. And we've also, Shona Friki in my lab, we submitted a paper with computational paper, which terrified me. It's the first time I published an equation that's we actually made up. This is terrifying. I mean, really. And that was crazier to me than buying analytical standards to vape. So we can actually make predictions now about how much approximate this type of e-cigarette, this configuration is bad. This one's good. We can just get a good ballpark estimate that I think would be useful to regulators. But I agree. Thank you.
There were a couple of hands over this way. Yeah.
Yeah, I have two questions, if I can. First off, your opinion, your personal opinion on CBD. I mean, it's everywhere. It's well publicized.
Yes, thanks for asking. You know, sometimes I kind of joke around a little bit. I know I maybe was a little, talking about CBD and it cures everything. My reflex reaction is to really try to give a little bit counter narrative to stuff that might be hyped. But seriously, I'm totally open-minded. And if the science comes out, if we could even get to it, and it turns out to be good for certain things, I absolutely wouldn't, I can't say either. So again, and I don't want to have an opinion, seriously, except if it's based on, science that I know, not just my science, but any science that I trust. And until then, I won't have an opinion again. I don't want to have it. I appreciate you asking. I'm not trying to get the question. What I can tell you is I'm totally open-minded about it.
And my second question, and of course you can see how detrimental it is now with vaping, but it's just going to continue and get worse, and they're going to try to recreate the chemistry, of course, with studies as your own coming out to where, okay, we're going to make it differently, we're going to make it more efficient, and it's just going to continue to bolster the market and sales, and they're going to push it and promote it. Where do you see this in 5 years as far as the negative on that? It's probably very detrimental, I could imagine.
Yeah, they started something just a few years ago. The whole tobacco control landscape has totally changed, and you have big business and lobbyists and advocacy groups, and it's just like cigarettes supersized. The cigarette controversy those days just supersized now, and I don't know. I can only hope. What we do is just try to present the data, say how we did it. So if we made a mistake, people say we reproduced it and we got what you got, and it was wrong because fine. But what we're trying to do is produce the data so that people that can make the decisions can make the proper decisions. I don't know where it's going to go. It seems like every week there's a surprise. Like I said, they haven't been good ones lately. So it's concerning. And you're absolutely right. I don't know. I said the other day to one of my students, I said, what are they going to be doing in a few years after e-cigs die out and all? Hey, who knows? It's crazy. It'll probably keep me busy for a while. I won't be able to retire for a long time, which is good for me, but I wish there was another reason why. But thank you.
Next, go ahead.
Is there any data on the relative health risk of using marijuana leaves, or and actually igniting that with these electronic devices versus using the solvent-based extract?
So we did that. We showed that if you smoke the leaves, just like people have been doing for whatever, thousands of years, I guess. We have, those UN studies are over. We know what that does. Long term, it's not so great. It's not good for young people, and it's really bad for cardiovascular or chronic use. We know all this. And we, in our study, we did a lifetime cancer risk and lifetime, I didn't get very approximate, really rough calculation, but just to get an idea, whether smoking traditional leaf, flower, buds, whatever you call it, scouring the literature, getting all the data we could, and comparing that to the data I showed in that big table just now. And we found that the risk is less. But, you know, it only tells part of the story. But that's the only study so far. It's the only one. And it's incomplete because we've only looked at the gas phase products. We haven't even looked at the particle phase. What's it like if THC is being delivered as a nanoparticle? We don't know. We haven't even gotten there yet. So I only looked at the gas, and most of the gas phase products, there's no tox data on them. There's things we found, so we can't really tell. But it looks like, as you'd expect, it's a milder way of inhaling, but again, you know, there's nothing new. It's still the Wild West. It's scary to say it's the only paper so far. I'm sure it won't be for long. And hopefully other people will help clarify questions like that. It's important. Thank you.
Okay, in view of the hour, I'm going to stop formal discussion right now, but I think Rob would be willing to answer more questions individually. And let's thank him once again for a very
I saw her.